Okay, hi everybody and welcome to TGIK. I'm your host, Kris Nova. It is really hard for me to talk today. I was losing my voice, but I've been drinking a lot of Heptio tea to help get my voice ready, and I've been trying not to talk all day long just for TGIK today. So anyway, welcome. Happy Friday, everyone. I'm back in Seattle. It feels really good to be home, and it feels even better to be back here at the office doing TGIK for everyone. So today we're going to be talking about instrumenting a code base with Prometheus. But before we do that, let's do everybody's favorite part of the week, and I'm going to go back and see what everyone's been saying in chat really quick. Okay, so Lamati, first in line, as per usual. Good to see you, Lamati. Lamati, you'll be happy to know that I've been using some of your tea, or some of your honey in the tea that I've been drinking in my Heptio mug, and it's been helping a lot with my throat condition right now. Anyway, Suresh, hi from Hamburg. Mateus, hello. We have George on the Heptio handle, and I might talk there some too if my voice starts to get any worse. We have software groups. Hello. Hello from Oulu, Finland. Hello, Elysianio. Nadir, Moody, Roy from Toronto. Brian Lyles. I just saw Brian earlier this week. Hi, Chris. Brian, I got super sick on a plane, and it's been really hard to talk for the past 2 days since I last saw you. Craig Nicholson says, love it. I'm assuming he's talking about to my joke introduction. People commenting on silent. First time you're here, welcome, Nicholas. It's good to see you. Thanks, Moody. I actually feel pretty good. It's just my throat is really sore, so it's just really hard to talk. Hello from Montreal. Glenn says the slides look like real life. Oh, I lost my spot. Harshal, hello. Mateus, we already said hi to you. Let's see, hello from London. Hello from Velocity. Hi from New York City. Oh, hi, Dan. Good to see you again. Hello from Paris. Hello from, happy Hacktoberfest. Anyway, that's a lot of chats. It's good to see everyone. We got a lot in store today. I was busy all day yesterday trying to get some good example applications and example instrumentations put together for us today. So that should be a lot of fun. So let's jump right into the HackMD here. So George, did we already share the HackMD link up in chat? I think we did. Yeah, it's up there. Anyway, if folks want to contribute or add any of their own what's new in Kubernetes this week to the bottom of the TGIK doc here, feel free to do that. But we're going to start off here with instrumenting Go with Prometheus. So I wanted to call this one out. If you actually go and you search the internet for instrumenting a Go application for Prometheus, this is pretty much the best blog that I found. So hopefully this blog plus what this episode's about will be able to give folks kind of an idea of what it's like to first get your application bootstrapped with Prometheus instrumentation, and then actually go in and start crafting your own custom metrics and ultimately getting those to a Grafana graph. So that's kind of the prompt for today. Okay, yeah, George added his HackMD URL again. Thanks, George. Okay, so we'll be looking at this a little bit later, and we're actually going to go through, and this one here is the example of adding your own custom metrics, so we'll try to get this up and running. But you want to go ahead and bookmark this if you want to follow along at home. Okay, so next, I wanted to point out Joe's Prometheus TGIK that he did earlier this year. And the assumption of today's episode is kind of picking up where Joe's left off, which was getting Prometheus up and running. The only big fundamental differences between what we're doing is Joe's using the CoreOS Prometheus operator, and I have all the raw YAML. And we're going to kind of go through things on my end a little bit more granularly, because we all know that I like to kind of break things down to the raw components so we can see where the rubber meets the road. But if you haven't watched this one, it might be a good idea to go and at least watch this at 2 times speed before you come back and watch this episode, just so you get caught up with how Prometheus works and all the different components and how they all fit together. So that's a good link as well. This was another one that I saw on Reddit earlier this week, and this is a really good blog that talks about all the different types of auto-scaling that are existent in Kubernetes today. The reason that I liked this is because a lot of these auto-scaling primitives are ultimately going to talk to the cluster API or at least that's been like the word on the street. But this is good because it'll go through and actually tell the difference between like the horizontal pod autoscaler and the vertical pod autoscaler, and then the cluster autoscaler, which actually will autoscale infrastructure underneath your Kubernetes cluster for you. So this is good if you want to check up on all the different types of autoscaling. One of the big things of Kubernetes is this new hotness is supposed to be super scalable. And with these 3 types of tools, you can actually go and scale your cluster. Mike says, hi from New Jersey. Hi, Mike. Good to see you. Thanks for joining, everyone. So let's see what's up next. We have step-by-step CRDs. So this was an interesting blog that I kind of skimmed over a little bit before the episode. I love the idea of advertising that CRD is inflexible and that folks can be using them. And anytime I see like a hands-on, you can go through and perform these steps and you run this code and it will work for you. I think that's a really great way for folks to learn. But this is basically like a step-by-step go through, and it's got this GitHub repo here called Harbor Kubernetes Project Initializer Tutorial, and you can actually go and download code and actually see how a CRD exists in Codeland. In fact, let's just go ahead and pull this up really quick. So yeah, how it works. A CRD, oh, there's a typo there if anybody wants to contribute to the project. Project is created and it uses, initializes the trigger creation of sub-namespaces and grants a user access with role bindings. An RBAC role, yada, yada. And then here's the tutorial down here as well, and you can see a demo. But yeah, if you're interested in CRDs, they're useful because you can define your own primitives and ultimately build your own operator that updates its status. That's really handy. And you can use that to actually build out things for you in your engineering org that would help you not only with Kubernetes, but also with whatever businessy, logic-y stuff that might be important to you and your friends on your team. So CRDs are really cool, and if you're kind of overwhelmed by how they work and what they are, this blog here is a good starting point. So let's go back here. Oh, this one's exciting. Okay, so earlier this week I was in London before I was in New York for VelocityCon, and there was this really cool conference, and this is our 2nd year doing the conference, and I was invited to come speak, and I really feel like this is a great mix of the cloud native space. One of the cool things that they did is immediately after, like down to the hour for mine, but immediately after folks got off stage, they had like a live recording that you could actually go and watch. So if you're interested in watching any of these talks, they're all free. You just have to sign up, and you can go through, and you can actually learn a lot about cloud native and Kubernetes from the thing that happened earlier in London this week. So it was a really good conference. Thanks for having me out there. And of course, everybody's favorite talk here, declarative infrastructure with Kubernetes. You can go check that out if you're interested. So that's a good resource as well. This last one, before we get into the Prometheus-y bits, is here in the Prometheus documentation, there's this sub category here where you can actually go and learn about the Prometheus query language. I'm not the best Prometheus queryer, but if you want to learn more about it, and we're gonna come back and reference some of this a little bit downstream. Oh, nice, a Thanos talk. Yeah, I almost thought about doing Thanos this week, but I picked Prometheus because it just seemed like a little bit easier because I knew I wasn't feeling super well. But I'm really curious to find out more about Thanos, so that's really exciting. Anyway, with the query language, you can come in and you can actually build custom queries, and you can like group on all these different labels, which we'll be looking at a little bit later. And these are some really good examples that you can, I think, understand pretty quick off the bat. Where a method is not equal to get, we want to see how many HTTP requests total for a given environment here, which is handy. So yeah, this is a good reference as well as we get into graphing some of this in Grafana later. Okay, so those are all the references we have for this week in Kubernetes. If anybody has anything else, feel free to add it to the doc and we can pull it up, or just ping me or George and we can jump into it a little bit later. So to get started here, let's show folks what I have set up. So if you go to the TGI repo, and actually let's do this in GitHub. It's going to be a bit easier. If you go to the TGI repo, and then you can go into the episodes 52 directory, I've pretty much made like a tiny repository here, and this is where we're going to be working out of today. To just give folks an overview of what we have in here, the repository, we have this thing called bundle.yaml, which this is going to define all of the Prometheus-y and Grafana-y and alert monitory stuff that we need to install in Kubernetes. And let's go through this a little more granularly to actually see what we're setting up. So the first thing we do is we're going to set up a monitoring namespace. And after we have our monitoring namespace, we come in and we define this like really wordy config mappy thing here. Scroll all the way down and you can actually see that this is a config map. And this is the actual configuration for the alert manager, which is one of 3 components that we're going to be looking at today. The 3 things are going to be Grafana, which is the graphing component, Prometheus, which is effectively the data store, and the alert manager, which I'm not very familiar with. I kind of left this one a little bit dark so we can explore some of it live, which is what this configuration here is for. So we define this config map for the alert manager. We also define this other config map, which has more YAML config-y stuff. Okay, and I think this is actually where we define the different alerts that we could be using. So we might come back and poke at this section later. We have a deployment for the alert manager. All of this is going into the monitoring namespace. And all this does is it pulls the Prometheus alert manager container that is pre-built for us and, gives it a couple of simple parameters here. We tell it that we want to listen on port 9093, which will be relevant in a second. And we map some volumes to it as well. Let's see what Suresh has a comment. Source graph was open source. Perhaps it might be helpful for people. What is source graph? Source graph. Now I'm just curious. Source graph is a free open source self-hosted code search and intelligence server that helps developers find, review, understand, and debug code. Interesting. Is this, Suresh, is this what you're talking about when you say source? Oh, yeah, source graph. Yeah, I typed that right. Okay, yeah, this looks interesting. I would be curious to check out a little bit more and see this offline. Thanks for the share. Mateus says, the first config map was for the templates and how the format alerts, and the second was for the alert manager itself. Okay, thanks, Mateus. So next we have a service that's going to point to the above deployment. The only change I've made to this one is I went ahead and changed this to type load balancer. The reason I changed all of our services to load balancer is so that we can easily pull them up here on TGIK, and we're only going to keep this cluster online for about an hour. Normally I would want to do something like have a formal ingress or do some other way of handling the ingress into our cluster, maybe even doing some port forwarding. But in this case, I took sort of the lazy approach and just set everything to load balancer. And we actually had to change some firewall rules, which are in the documentation that we'll look at in a second. So next we have our Grafana core. So this is the actual Grafana component itself. So this is a web UI that's going to read the data we're storing into Prometheus. And again, this is just pulling the Grafana container. We're defining some resource limits. So really quick, can I just rant about resource limits? I'm seeing more and more deployments go in that have the resource limits defined. These are really important to define, or at least give yourself a starting point so that as you scale your application moving forward, you have sort of a finite block that you can keep in mind that your deployment will never exceed. And as we look at actually breaking our cluster a little bit later, having these resource limits defined would be super handy so that we don't put our nodes into deadlock, which I was able to do last night. Anyway, going off on a tangent. Let's keep going. Also, we have a readiness probe, and also I can't advocate for that enough as well. That basically just says that on port 3000, we're going to do an HTTP GET to login, and as long as that returns a 200 OK, we're going to consider this the pods in this deployment happy and healthy. So that's just a really quick way for the rest of Kubernetes to know that this deployment is online and is functioning as expected. This is handy because you really don't need to do anything more than just be able to return a 200. So here we're just hitting the login page, which we know would return a 200, so we don't even have to build any extra logic for it. It's just a handy thing to define. Let's see, we have more stuff in chat. Diego, hello from Norway. And I'm going to butcher your name, I'm really sorry. Krunislav, hello from Croatia. Okay, hi both of you, thanks for joining us. Update for folks who weren't here at the beginning. I'm pretty sick and my voice is going out, so at any point if it quits working, we're gonna switch over to chat. But for now, it seems to be doing pretty well. So Mike Merrill says, sometimes the alert manager config needs a secret, like a HipChat token, forcing me to make the entire thing a sealed secret, which is pretty unsightly. Oh yeah, putting secrets into config maps is like, I see a lot of folks do it. I would never do it, but it's a really hard problem to solve and super annoying as well. So thanks for pointing that out, Mike. Okay, so it looks like we have another config map here. Also, if you are defining YAML for other folks to use, I really enjoy to always do the API version first, and then in the very next thing, I really like to always have the kind, just so right away, folks who are inspecting this YAML or thinking about running it in their cluster know right away what it is. In the case of the config maps here, we have a ton of data, and we have to scroll all the way down before we even see that it is of type config map, which I guess at this point it's pretty self-explanatory, but that's just a thing that I like to do. Anyway, so this whole block of text that we're looking at here, let's scroll back up. So this is the Grafana core, and this is all of the, oh, sorry, I already looked at that. This is not the Grafana core, this is the Grafana dashboard, and this is all the configuration for Grafana itself, which a lot of this is defined for us thanks to this lovely repo here. Where was it? Kubernetes, Prometheus. Let's try this. This one here, this giant swarm repo. I should actually put this in the docs. Is where all of this YAML that we're looking at originated, and then I modified it on my end and stuck it in the repo. Hi from Maine and hi from Chicago. Did this not want to open? There we go. Let's add this in here. Original source of Prometheus. Bam, bam. And let's get rid of this one. Okay, cool. But yes, if you want to come and check out this repo, this is where all of the stuff we're looking at now originated. Okay, so let's scroll down past our Grafana configuration. I know I'm going kind of quick here because I think a lot of this was talked about in Joe's episode, and the Prometheus operator can get rid of a lot of this noise for us as well. So if you're interested in coming through and figuring this out and modifying Grafana, this is the place to do it. And there's a lot here. That's why I don't really want to go into it. Okay, so finally down here on line 2245, we see it's a config map, and we can move on to our next resource here. Hello from Hamburg, Germany. Hello, good to see you. So this next one, we define a job, and this is the import dashboards job, and we come down, we can actually see the job definition itself. So here's our spec, and you can see that we're mapping it to a service account, and we're mapping it to a handful of containers, and we have some, what looks like bash here defined that we're running for our job as well. Now, I don't actually know what this piece is doing. Anybody who's familiar with how the Grafana system works and how the import dashboards component here works, it would be helpful for a little bit more information here. Let's move on. So we have a service for that, still in the monitoring namespace. That's going to be a theme for today. We have a deployment here, and this is the Prometheus core. And if you watch Joe's episode, you'll realize that Prometheus is basically a data store that stores sets of values, and those sets of values we call time series data, and that time series data can then be reflected using a graphing service like Grafana, but doesn't necessarily have to be Grafana. I'm so happy Mateus is on the call today. Mateus, it is importing all the dashboards via the Grafana API. Awesome. Thank you for that, Mateus. So anyway, here at the Prometheus deployment, let's scroll down. We're pulling the Prometheus container. We're defining some, looks like some resource limits, which is good. Not seeing any checks on this. And we're defining some volumes down here as well. So this all looks pretty straightforward. Next, we have a cube state metrics, which this basically runs the cube state metrics container. And this is probably the simplest deployment we've seen yet. That basically just listens on 8080. And this is going to basically expose some metrics for the Kubernetes cluster itself and the state of the cluster that we can then pick up later using Prometheus. So Mateus says Grafana v5 Plus can import the files directly now, so no more job or sidecar is needed. That's handy. Good to know. Thanks, Mateus. What is this? We have some stuff commented out here. Oh, if you wanted to set up RBAC, let's see what we have here. Oh, this is RBAC for cube state metrics. Okay, so if this was a concern for you, or if you had a very dispersed namespace cluster, you would probably want to come in and use this as a starting point to define the cube state metrics for a given smaller portion of your cluster. Elysianio says, just an FYI, that repo has very old versions of Prometheus and Grafana. Both of them have new major versions nowadays. Oh, thanks Elysianio. I just picked that one because it did not involve installing an operator and gave us just raw deployments that we can inspect along the way. But I'm curious now, like, what are the differences between Grafana 4.0 and 5.0? And let's see, Mateus says, yep, and the cube state metrics version 1.4 as well. My bad, folks. I just picked this again because it was the simpler alternative. But we're going to go with it for today, and just bear in mind that some of the components we're defining here could use a revamping to get the latest versions as well, which would probably be as simple as going through and updating this YAML file, but that's a different discussion for a different day. So next we have this daemon set. And this is node directory size metrics, which again, this is just another way of exposing metrics about our Kubernetes cluster. We know we're going to get a pod on every node because it's a daemon set. And then we're going to expose some metrics that we can pick up later. Saeed says, I use KSonnet to stand up Prometheus Grafana rather than raw YAML. Interesting. I know a lot of folks have been switching over to KSonnet more and more. Brian, this is your plug. I would really like to see, maybe I could come back at a later date and KSonnetify, if that's a term, this YAML here that we're using and abstract this even more to simplify it for folks at home. So I'm not having to go through this. I think is a really great example of like the dreaded wall of YAML that we're continually talking about solving with KSonnet. So this is like a picture perfect example here. So yeah, anyway, here's our node state metrics. And we define a container. We have this tiny tools container. And basically it just goes through and it looks like it loops through some directories and exposes some metrics about them by dropping them off in the temp metrics temp directory. Mateus says, no worries, Prometheus v2 has improved TSDB and Grafana version 5 has a new grid, so nothing urgent for this episode. Okay, as long as it's not like any sort of crazy breaking changes or any super major vulnerabilities, I feel pretty good about using these. And really the point of the episode is to talk about what we're doing in code. And I do make sure to use the most recent versions of the client libraries in the Go code. I'm just showing folks what I have up and running so they have an idea as we start looking at the code itself. Mateus says, Saeed, yes, and we, Red Hat and Grafana, including a lot of others, are working on JSONet for monitoring. Some principles, or the same principles, Google monitoring mixins. Thanks for that, Mateus. So where were we? Okay, so we looked at the daemon set. We saw how it was dropping off some metrics in the temp metrics directory. And we're running this other container as well, which is Caddy. And this basically runs on port 9102. And I'm assuming it exposes /metrics somewhere, which is how Prometheus is going to pick up our metrics here. So that's a pretty cool little trick there. We have another daemon set. This is the node exporter. What is this one doing? Container port 9100, host network, host PID. Okay, so I'm assuming this is doing some sort of exporting to push more node data up to Prometheus. So here we have a service for the Prometheus node exporter. Yep, I'm guessing that Prometheus is scraping this exporter, and that's why we have this service here on port 9100. And we're getting close to the end, I promise, folks. This last one is another big, not that big, but it's another config map here. So here's where we're actually defining the Prometheus rules. And when we actually look at our dashboard in a second, we're going to learn about rules and targets and why they're important. But if you want to come in and actually see things like the CPU usage or the instance availability or the load disk space rules, the logic for those are encapsulated and defined here. Mateus says, yes, the node exporter exposes a per node metric like CBU and memory utilization, and a lot more metrics. So yeah, I would say, like, in general, as I started poking around at Prometheus, and I'm far from an expert, a lot of metrics and a lot of data. And I think there's this whole exercise of like actually being able to make sense of that and find meaningful patterns that, like, to me seems like a really exciting space to be in and work in. And, you know, I think if you were really in a situation where you were using this stuff, it would be really fun to go through and actually have like your favorite queries and your favorite dashboards, because there's just so much stuff that we can get here. And we're going to look at how we can even add even more today by instrumenting our code base. So yeah, this is our rules definition here. So next we have some RBAC for Prometheus. So we're defining a cluster role binding. That one's really simple. We have a cluster role. So we're exposing node services, endpoints, and pods. Get, list, and watch. So that's pretty much read only, which totally makes sense. For the default namespace, we have config maps. We can get those, which is good because that's where we're getting our configuration from. And we're going to be able to hit /metrics on the get HTTP verb, which is handy. Solid RBAC rule. And then, of course, we tie that all together with a service account. Okay, finally here at the end, we have one more final service, which is load balancer on port 9090. And we're going to actually look at these services in just a second. Okay, so this is the YAML that we have up and running already. And if you go back to the documentation for today, this is all coming back together, I promise. This is all like gonna make sense in a second. The very first thing we do after we create a cluster in Amazon is we kubectl apply this entire bundle of YAML. So let's go and actually look at the cluster and apply this YAML just to show folks that it is up and running and take a peek at what we have there. So if we go to GoPath, source, github.com, Heptio, TGIK, episodes 52, we can go ahead and kapply -f bundle.yaml, and you will see that everything is pretty much configured for us already. So the interesting thing to point out as we actually want to look at what we have up and running is to take a look at our services here. So we can do that by doing kget svc in our monitoring namespace, which is where everything is running monitoring. And we want to do a wide so that we can get the full A records for our 3 load balancers that we're going to be using today. Let's see if I can simplify this a little bit. Okay, almost there. I'll zoom back in a second. I just want to get I just want these to be a little bit easier to read. Okay. So this first one here is for the alert manager. Here's our external IP address, and you can see this is running on port 9093. So what I did is I took the lazy person's approach, and I just went into Amazon here. Excuse me. Also, Heptio folks probably don't come in this room, at least until next week. This is like the quarantine zone. I should put a sign on the door or something. So let's go down here to our security groups. So for the nodes, and I am super lazy, I opened these to the world, but you can actually go in and open these up specifically to the load balancer that you need. In fact, we can change that right now. Let's be good citizens and actually do this the right way. So the first one is we're just going to want to do 9090 only, and let's see. We're going to want to open this up to, we'll just grep for this right here, to this load balancer. So in Amazon, you can come through, you can actually type, and it'll find the security group for that specific load balancer. So now we know that we have 9090 open to that one. Let's do another rule, which is going to be 9093, which is for the alert manager here. Chris Bargman, hello from Hamburg. Good to see you. So the alert manager will grab the first few characters here. And we can add that. And then the last one, port 3000 is going to be Grafana. And how we find Grafana is we find Grafana and we grab a few characters here. And there we go. Okay, so this is much more secure now. We've basically opened up our node security group, which is how Kubicorn sets up a cluster, to poke holes for the various firewalls that we're going to be using today. For 9093 for the alert manager, 9090 for the Prometheus dashboard, and port 3000 for Grafana. So now we can go back to our terminal and actually hit these. So let's get this one on port 9093. Let's close some of the stuff too. So there's our alert manager. Let's get this one on port 3000. Oh, and please, I don't want revenge of the rainbow vote the other day where I ended up taking the Heptio internet offline. So if you're gonna hit these at home, please be nice to me while I'm here on the air. This one should be 9090. No, which one is this? Yeah, it should be 9090. Let's see what's going on here. Michael, hello from Johannesburg. Did I copy the URL right? Let's see. Let's try this again. Nope. Okay, so this is really good because if I was debugging a load balancer in Kubernetes, these are the steps I would take. The first place I want to look is in Amazon at the actual load balancer itself to see if any of the instances are in or out of service. So how we can do that is we can come down and we can find the description here should tell us which port it's on, and that's going to let us know which service it's for. So 3000 is for Grafana. 9093 is for the alert manager, which we know is up and running. And 9090 here is for Prometheus. So you can come to instances and actually see that, yes, this is out of service. So there's our problem. So Joachim says hello from Sweden. Good to see you. So let's see what's going on here. I wonder if I typoed one of my security group rules when I changed it, because it wasn't working earlier. So port 9090, and this is going to be for, let's get the name again. The Prometheus load balancer. Save that and see what happens here. Let's open this in a new tab. Okay, so let's check this again and see if our instances, they're still not in service. Oh, is this a dreaded case of a load balancer in the wrong availability zone? I bet that's what happened here. So this is in US2B. Our node is running in, where is it? US West 2B. So this is fine. Everything's fine. But yeah, this is our basic cluster too, by the way. We only have one node online, so if we need to debug anything, we know it's just going to be running on that node. So let's go back to our load balancers and see what we see. Out of service. Instance has failed at least the unhealthy threshold number of health checks. So I wonder, let's see if anything's going on in our cluster. And before we do anything else, let's do the shortcut where we create a new kubectl alias for the monitoring namespace. Gustavo, hello from Chicago. It's good to see you, Gustavo. So let's do alias km is equal to kubectl namespace monitoring. So now I can km get PO. Here we go. There's our problem. Let's see what's going on here. So this is cool because we're actually getting a little bit of like live Prometheus debugging, which obviously after looking at that YAML file that we just looked at, there's a lot going on here. So getting all of this set up right and getting this kind of stable is a task within itself. And we're going to look at that when we look at how Prometheus monitors itself in just a moment. Mateus says, was the autocomplete for the security group correct? Do you need to forward to the node port and not the service port? Mateus, I think it's just something's going on here, and let's see what's going on with this Prometheus core. Maybe I accidentally like put in a character or something in the YAML file when I reapplied it a moment ago and messed something up. But how I want to do this is let's get our logs for it. So we're going to do km logs, the name of our pod, -- previous. Again, if you haven't seen this -- previous command, this is one of my favorite tricks. It's actually going to show us the logs from the previous pod that failed, and we can see what's going on. Matea says, yes, never mind, with the innocent emoji. In general, I would say that I'm really happy with the amount of emojis in the TGIK chat. I just wish it was easier to add emojis. Carlos says, hello from Raleigh. Hello, Carlos. Good to see you. And Felipe says, kubeNS monitoring is great. Smiley face, or winky face. But yeah, that's definitely a winky face. Okay, so let's run this. Flag storage local memory chunks is deprecated. Its value 5,000 is used to override. So that's our warning. Here's our error. Okay, let's see what this error says. Couldn't load configuration. No such YAML file or directory. Etsy Prometheus bundle.go. Let's go and let's see if my bundle.go has any typos in it. Or not bundle.go, bundle.yaml. Oh my gosh. Okay, so here's our config file. Let's see where else we can find this. Okay, so this only appears once, but this has got to be coming from a config map somewhere. You know, I'm wondering if I can cheat and just totally revert back to a previous version. Let's go look at GitHub and see if I introduced a change earlier today. I bet I did. github.com/heptio/tgik. You guys are getting to see the true Kris Nova, super lazy and always trying to take the quickest way out, which I guess is a good thing, right? So how we can do this in GitHub is we come into episodes, we go to 52, and we want to see our bundle.yaml. And this is a really handy feature of GitHub as well, that if you're not using this, this can totally save you a lot of time. There's this history button here. And if you click on history, you can actually see, yes, 2 hours ago, I made a commit. Let's see what we have here. Let's see what I did. So I removed time and math rand from the main.go. That's not going to be a problem. But here I changed load balancer and node port. And then I also added our show notes. So this looks fine. Let's see, so Bogdan says, hey Kris, when dealing with one pod services and even with deployments in co, I feel like kubectl port forward is much more convenient than externally exposing them. I totally agree. I just wanted to demonstrate the different ports they were working on, and I was working on this from home earlier today, so just having them online just made it easier for me to move back and forth between home and the office. But yeah, port forward works just as fine as well. Earlier I mentioned that it might be even better if we added an ingress to this and just wrapped all of the different things in with ingress, so that would be cool also. But yeah, definitely more ways to skin a cat, especially because load balancers definitely are not cheap. But thanks for the tip, Bogdan. So I'm wondering if I deleted this and this is causing some problems. So what we can do is we can actually go back, grab the raw version here. We're going to clobber our bundle.yaml, and let's grep for node port. Wait, did I type that right? So wait, type equals load balancer. That should not be what we want. We want the previous version. So let's go back here to this commit, and let's view here. That's the Prometheus.yaml. I want the bundle.yaml here. And we'll grab our raw one, and then all we're going to do is just change type equals node port equal to type equals load balancer, and that should make no change. So let's see here. So node port, and let's change that to load balancer, and let's find the next one and change that to load balancer. And let's find the next one, and we'll change this to load balancer, just because we already have the rest of the infrastructure in place. So let's see if we can get a change here now. kapply -f bundle.yaml. And let's km get PO. And let's see what's going on here. See if we can't restart this one. km delete PO. Bam. Still in crash loop, back off. Thomas says, what I've been doing so far is just using an ingress for Grafana, but doing port forward for Prometheus Alert Manager if I actually need to get to them, which should be rare. That brings up a really good point. Prometheus and Alert Manager is basically just going to handle mapping our alerts for us, and the Prometheus dashboard is basically just a quick and easy way, just for me, that I found useful, is just to make sure that it's online and up and running. But yeah, ideally you should only be interacting with Grafana, and then the Prometheus configuration should be changed rarely, if at all. Mateus found it for me. This line needs to be, bam. Okay, so let's see what Mateus says. I love when people help me out. This makes my life so much easier. Episodes 52 bundle.yaml line 2374. Prometheus.yaml and not bundle.yaml. Awesome. Good find, Mateus. You're just like saving the day today. So line 2374. Let's go find that. 2374. I still haven't found a good way to jump to a line in Goland yet. If anybody knows, let me know. 2374. Here, it's 76 now. Prometheus.yaml. Good find. So k applied minus f bundle.yaml. And let's see. km get po. And I think we can do a dash w and watch and see what happens. So our import job is completed. Our Prometheus core is terminating, and our Prometheus core is up and running. Hats off to Mateus for saving the day. Okay, so now let's do our service command again. Km get svc dash o wide. Okay, so those all look the same. So our cloud provider hasn't mutated the load balancers from underneath us. So drum roll. Let's see if we're finally going to be able to hit this. Yay, the Prometheus dashboard is up. Okay, so the Prometheus dashboard is up online, and here are the rules and targets that I mentioned earlier. So as I've been learning more and more about Prometheus, these are the two big things that I have found myself coming and checking in on. So let's see what's going on in Slack. Oh, it looks like people are retracting their message. And Bogdan said Command G. So I think that's a little bit delayed from when I was debugging a moment ago. So anyway, let's take a look at the rules. So this is where we're defining some alerts, and this is you can almost read this like regular English, which is handy and good to know. So the first one is called node CPU usage, and it says if 100 minus, there's this formula here, by instance times 1,000 is greater than 75 for 2 minutes, where the levels severity equal to page. So this is a label here, not levels. And this annotation, go ahead and send an alert, which we're going to look a little bit more at alerts a little bit later. And Mateus says the alerts are now YAML in Prometheus v2. Oh, that's handy. So that means we don't have to actually go and learn this new language here for defining alerts. Oh, so that's good to point out, that we would be configuring YAML, more YAML, yay, for the alerts in Prometheus v2. So that's a big one that I would be interested in using. So let's take a look at targets. And I'm almost out of tea. I might have to can we do like an intermission and like put on a commercial while I go get another cup of tea here in a second? Okay, so these are our targets. So the targets are basically the different data sources that are going to give us information about what's going on. And Prometheus is going to store those for us. So what's interesting is if we actually look at these /metrics endpoint on the Prometheus server, we can see that these are the metrics that Prometheus would go and scrape. So basically, it's just an HTTP server that spits out these metrics that Prometheus can then come and make sense of. In Joe's episode, he talked a little bit about how you would want to sort of structure these metrics if you were creating your own. And we're going to look at those a little bit later when we actually do the tutorial. Dan Bentley says T, as in T, GI-Kates. Yes, that would be nice. I actually have another cup of tea at my desk. It would take me like 4 seconds to go get it. I really might do that in a second, just because my voice is already starting to hurt. So anyway, the /metrics API can be found here on, actually we're not monitoring it. So we could add a target, which it doesn't look like we have, where Prometheus could monitor itself simply by scraping basically localhost on the /metrics endpoint. So again, the YAML that I found gave us very simple targets to start off with, and that's not really like the point of today's episode, which is how do we instrument a lot of this in Go. So today, we're going to be focusing on this bottom target here that is sort of intentionally broken. That is the TGIK app that we're about to take a look at, and then make a Docker container, run it, and then create a target for it and re-update our Prometheus configuration. Okay, 45 minutes just to get here. Got to pick it up. Okay, so if we go into our repository, here we can see, ooh, I don't want to tree all that. Let's just do a list log. Okay, so we have a Docker file. We have two Go package files, which means we're using dep. We have a make file, a readme, the bundle.yaml that we're all very familiar with now, the Prometheus.yaml, which we're going to take a look at in depth when we look at adding our target. We're going to go through that one, and our main.go, which this is the meat and potatoes of our program. So in my IDE, bam, we can pull up our main.go. And there's a lot of stuff commented out here because this was sort of me playing with metrics earlier. And then I've got some example HTTP server-y stuff down here at the bottom with an example handler if we decided to actually write a separate HTTP service on the same container. So Thomas says, anyone has any thoughts on deploying Prometheus manually versus Prometheus operator? I've been using the latter so far, and it worked all right, but curious what I might be missing here. So yeah, Thomas, in Joe's episode, he used the Prometheus operator. I took a different approach because I'm a big fan of keeping things simple for TGIK so that folks can really see the different components under the hood here. And also, we've already done an episode on the Prometheus operator. When I was setting this up, I did play with the Prometheus operator. I found that the documentation was pretty good. There were still some things that I found missing along the way, but once I got it up and running, it worked really well. And just the TLDR on the Prometheus operator is it takes a lot of the configuration that we just saw in our bundle.yaml file and simplifies that by creating 3 new CRDs in Kubernetes that you can then interact with configuring your Prometheus setup with through those CRDs so that you're not going through and pushing changes like we're about to do today. So sort of like the high-level differences and pros and cons there. Also, anytime you adopt any sort of operator, you're adopting another dependency, and you got to look at things like how often they're releasing, who's maintaining the project, so on and so forth. So Harshal says, yeah, I want to see Harshal's response here as well. Thomas, the operator is a little painful right now as they are updating their Helm charts and not accepting new PRs. That was another thing. I try to, again, in the name of keeping things simple, I try to stay away from configuration management tools like Helm or KSonnet purposefully, kind of to demonstrate the pain a little bit and just so that we are working with as raw of ingredients as possible. So Harshal says, Thanos implementation, for example, is not possible with the present Kube Prometheus chart. And Matthias says, if you're running as a single tenancy in your Kubernetes cluster, stateful says should be fine too. The operator adds a bit of sugar on top, but especially for multi-tenancy, it's interesting. Great feedback, folks. Thank you very much. Okay, so let's look at our main function here. So to start off, we have, actually, let's just start off at the top. Why not? Package main, we're importing flag and log and net HTTP, and then our 2 dependencies here are prom HTTP, which this is the Prometheus-sponsored client Golang library. So let's go look at this thing really quick. This library is pretty solid, but there are 2 main parts here that you're going to want to know about. Matthias says, disclosure, I'm a maintainer. Thank you for pointing that out, Matthias. I did not know that. So yeah, if you can tell us about the release cycle and stuff, that might be a good tidbit for folks to know as well. Anyway, the Prometheus client Go library here, the 2 parts that I found were, if we look in Prometheus, so this is all, I'm trying to remember, like I remember there was somewhere in the documentation that said this. Instrumenting applications. Okay, so the model package has been moved. Here we go. So the Prometheus directory contains the instrumentation library. I wanted to make sure I said this right, so I actually want to read this. See the best practices section of the Prometheus documentation to learn more about instrumenting applications. So the Prometheus directory here is actually the code that we're going to be vendoring and using that actually is going to help us calculate metrics and then serve those metrics on the /metrics endpoint for our program. So basically all we're doing is we're importing this library, and then they have like the default HTTP handler, and we're going to be using that today. Matthias says, with the JSON-based approach, Thanos is easy to add with the sidecar. Okay, so let's go back to our application here. So the first thing we do is we call flag parse. This is like the Go idiomatic way of parsing flags, which normally I like to use something like Cobra because it's a little more feature rich. But for this example, this basically gives us two flags, one for the metrics address, and then if we also want to have a separate HTTP server, we could also pass in a port for the address for the HTTP server, which is the bit commented out down here at the bottom that you can see here. So those are the two inputs to the program. And the very first thing we do is we say we're listening on the metrics address, and we spit out the metrics address that we're listening on. For anybody, whether you're writing an application that's going to be monitored with Prometheus or just running in Kubernetes in general, I cannot overstate the value of simply echoing what address you're listening on. There's anywhere from 3 to 6 layers of network traversal between your actual program running and potentially where you're accessing that program from, and actually having the raw address that the program itself is running on can be very handy if it ever comes time to debug. So this is one of the first things I'll put in a Go program that I'm running in Kubernetes, just to help an engineer if they are debugging downstream later. So then we do HTTP handle on /metrics, and the prom HTTP handler, which this is in that library we just looked at. If we go and we look this up, we can read about it, and it says, the handler returns an HTTP handler for the Prometheus default gatherer. So the default gatherer, we're going to look at that in a second. The handler uses the default handler ops, which is just an empty struct defined here, i.e. report the first error as an HTTP error, no error logging or compression. So the this new default gatherer, or wait, what function are we calling here? How do I go back to this thing? Prom HTTP handler. So this basically just hard codes the handler options. But if you wanted this thing to be a little bit more granular, you could come through and let's see. I want to edit this file anyway. And you could come through and do things like configure compression or error handling or error logging, which would be cool as well. But we're just going to keep the defaults for the example today. And the default gatherer, so this is a really interesting piece of code here. Let's look at the gatherer type. So the gatherer is the interface for the part of a registry that is in charge of gathering the collected metrics into a number of metric families. The gatherer interface comes with the same general implication as described in the register interface. So all we have here is this function called gather, and it returns a set or a slice of metric family pointers, and then I'm assuming an optional error here as well. So it would be possible to actually go and write your own metrics gatherer and just simply implement this interface and use it for the use the rest of the program's scaffolding around it as well. And if we actually go and look at the metric family, I know we're getting off in the weeds here. We cannot look this up. Okay, that's probably a sign. We're going to skip on that for now. But a metrics family is just a grouping of metrics that you could optionally define, and that's all that gather does. So going back to our main function, we are keeping things very simple for this first example, and we can play more with this in a little bit. If folks want to drop into chat anything specifically they want to see, I'm happy to demo that live. But we get the default one, and we are just going to listen on /metrics and output the output of this prom HTTP handler here, or whatever that it resolves based on the HTTP request rather. Okay, so the next thing we do is we say logger always. This is my Cubicorn logger, which is just a rainbow logger, but you can use good old regular log or your own logger or whatever if you want. So this has no relevance to running Prometheus. Anyway, I just simply echo out that we do have the /metrics endpoint registered. Again, this is for debugging. And then this is another big log line that I can't get on my high horse enough about this one. Anytime you start a server, which is this next functional line here, in Go, please, please, please have a log that just says you're starting the server so that you know that the actual server is starting, and that's why your program is hanging. I can't tell you how many times that I've just execed into a log or into a container, tried to pull logs or something, and I get the logs and it's just nothing, just sitting there, and you have no idea what's going on in the program or if the server even started. So this is a good one to do as well. So then we wrap up HTTP listen and serve on the metrics address, and we log fatal that. So now our /metrics endpoint is returning this handler every time we have an HTTP request to it. So let's run that locally. So we can do that by doing go run main.go. Let's do a quick dep ensure. So I have this running on my Linux computer at home, so I might not have pushed up all of the dep dependencies in my dep ensure that I did. I think I did it yesterday, so that would probably make sense. So now let's try this again. Go run main.go. And that also explains why we weren't able to look up the metrics family type as well. Okay, cool. So here's our color-coded logger, and it says we're registering metrics on localhost 1313. In Go, if you don't define the first part of an adder that's delimited by this colon here, it's just going to listen on localhost. So that's the syntax there, and we know that the server is up and running. So Go program running here on my local, I should be able to hit localhost 1313, and I should be able to hit /metrics. And poof, Prometheus metrics running on my local machine here. So now all we need to do is get this up in Kubernetes and then expose it so that Prometheus would be able to actually go and scrape these metrics for us. So how we want to do that is we want to containerize our application. So I have this same makefile format that I use for pretty much all of my projects. I encourage you to come through and look at it. It's pretty handy, and it's got this really cool little help section here that basically says all you have to do is do double comment and then whatever text you want next to a target, and then you get that help command for free. So this is pretty cool. So if I delimit this and zoom in, I can actually go to my Go path source, github.com, Heptio /TGIK 52, episodes 52. And I can do make help, and you can see that my makefile spits out color-coded description of what everything does. So our makefile has clean, which is just clean the Docker images, make, which will build a container, and then push up to a Docker registry. I've already done a Docker login, so in order for me to build my application that I know is running here on my local, I should do make container push. It's going to send our context to the Docker daemon and actually build this container and push it up to Docker Hub for us. So the Docker file is super, super simple. It just maps episodes 52 to the container and then says go run main.go. Keeping things super simple so that folks can see where the rubber meets the road here. Because really what we care about is the software engineering that's going into this, not necessarily Docker container best practices right now. So let's go back to my terminal. Okay, so that's pushed up to Docker Hub. So now we want to actually run this application in our cluster. Right now we're going to deploy our application to the monitoring namespace, but we don't necessarily have to deploy the application to the same namespace that Prometheus is in. There would just be another concern of setting up RBAC that I felt like was out of scope for the episode as well. And if folks have questions on that, I'm happy to give a quick little demo on how to get your application running in a different namespace if you need some help along the way. But to keep things simple today, we're going to put everything into monitoring as well. So how we do that is I actually wrote the command for us because I'm good like that. How we're going to run this is we're going to do a kubectl run. I thought about actually going and writing a deployment proper for this, but I also feel like kubectl run and kubectl expose are handy commands that don't get used nearly enough, so I want to give them a little bit of love today. So let's do kubectl run. So let's look at our command here. Okay, so we did kubectl run TGIK app in the namespace monitoring -- image Kris Nova, which is my Docker Hub user, TGIK instrumentation app, and if we go and we look at my makefile, we can see that that should all line up here at the top. TGIK instrumentation app is the name of our target, and the registry is Kris Nova. So actually, let's go back. Actually, I wanted to change something about this deployment, and I forgot to update the docs. So this actually might be a good use case for actually having the deployment YAML in the repo here. but we're going to edit it, and I'll just show you what I need to change. So we're going to do our km command. Actually, we don't have km in this session, so let's just do kubectl namespace monitoring, edit, deploy, TGIK app. By default, the image pull policy is set to if not present, I think. Let's see. Where's our image pull policy? No, it is. It's set to always. Okay, that's good. For some reason, I thought that image pull policy was not set to always, which meant as we look at updating our application, that was going to be a bit of a pain for us. So we're good there. And we can do a kget PO in our monitoring namespace. And actually see that the TGIK app is now up and running. So we're still not quite there yet. And I'm going to switch back over to this terminal. I stopped the program because I want to use that KM alias we defined earlier. And I'll zoom in a little bit more here as well. There we go. OK, cool. So let's go and let's actually look at the Prometheus targets here. So if we refresh this, you can see the last scrape was about 6 seconds ago, and we're still down because we don't have a service up and running for this deployment we just created. And Prometheus is going to need to access it on the network somehow. Sorry, friend was visiting. So let's actually use the kubectl expose command to create that service for us. So let's go to our docs, which is here, and here's our expose command. And if you remember, we were running on port 1313, so that's why we have this -- target port and -- port. Earlier I had mentioned there's several layers of network, just networking noise, to be frank, between your program and actually running in Kubernetes. So here's a great example of we're going to listen on port 9093, but we're actually going to re-forward that onto port 1313. For the program or for the container that's running the program itself. Okay, so let's go and run this command. Kubectl expose. Resources were provided. Oh, kubectl expose. Okay, so I have my syntax wrong here. You have to tell it which resource you want to expose. You can expose different resources like stateful sets other than just deployments. So that was my error there. Okay, the rest of this looks good. Okay, so service TGIK app exposed. So now if we go back to the Prometheus dashboard, let's see. Let's refresh. It takes it a second here, but this this should get up and running. Actually, let's double check really quick. Let's just look at what's going on here. So earlier I had mentioned we had to define a target in this Prometheus.yaml file, and I think it's finally time for us to bring this thing up. I was kind of holding off on it because there's a lot going on in here, but we can totally take a look. So in this Prometheus.yaml file, we have this really, really important directive here called scrape configs. And if you go look at the Prometheus documentation, you'll see that this is actually like the magic place where you go and you define your different targets, which is ultimately how Prometheus is going to know which pods you want to monitor as well. So if we scroll down to the bottom, we can see that this chunk here was pre-populated by the YAML that we stole out of the repo, as was this snippet, as was this third one and this fourth one, and then all the way down here at the bottom, I feel like I should do like the same thing and add like a comment here. Kris Nova TGIK app target. That looks good. This is the world's simplest Prometheus target because I wanted you guys to see what's going on here. So we give it a job name, which is TGIK app. We tell it we want to scrape every 10 seconds, which we could actually bump that up and do every 1 second and really like hammer this thing. And then for the static configs, you come in and you define multiple targets. And in this first target, we are going to use kubedns to point to the TGIK app deployment on port 9092. And I think this is our problem here. So 9092, is that what? Aha, 9093. So I found our problem. 9093. So let's go ahead and reapply this Prometheus.yaml and update our configuration. Sorry. 1 second. Okay, so how we want to do that is we want to k-apply minus f prometheus.yaml, and that's been now configured. And if we get our pods, let's go ahead and restart our Prometheus core here. And let's do it, instead of killing the pod, I am going to try a different way of resetting this. So I wanted to use the scale command, which also I feel like does not get quite enough love. So we're going to do k-scale, the resource we're scaling, which in this case is the deployment, slash namespace monitoring, TGIK app -- replicas equals to 0. And so we should have no pods running now, and then replicas equal to 1, and now we're going to create a new pod. So I think that's a little bit easier to do because now I can just look in my bash history and I can just find either of these commands, and all I need to do is flip a switch here and change a 0 to a 1 and run the command twice instead of looking up the pod name every time and copying and pasting the pod name every time. So for a developer, it's just a handy trick. Okay, so if we go back to Goland, we can see we're on 9093, and let's go back here and let's refresh our page, and TGIK app 9092. What's going on here? Context deadline exceeded. And why does it still think we're TGIK app 9092? Did that target not get updated? Let's go look and see. Why would this thing not? Let's just make sure that this is actually deleting the pod so that it's getting reconfigured. Ah, okay, so that's not what's going on here. Oh, because, okay, duh. I'm scaling the TGIK app, not the Prometheus. Prometheus, thank you. Yeah, Mateus noticed it too. I just did my scale thing wrong. Okay, so instead of doing the TGIK app, which we want to set that back to 1 first, we want to do Prometheus core. Typo on my end. I'm going to blame the Dayquil. Prometheus core. Oh, and Mateus says also you can curl localhost 9090, and it looks like there's this reload endpoint as well. Oh, so let's actually try to do this really quick. So I'm going to grab his command. That way we don't actually have to scale this. So let's go back to Chrome. Then it reloads, Mateus is saying, then it reloads in flight and no need to take down Prometheus. Oh, so this is, excuse me, super handy. Actually, we don't want to do that in Chrome. Let's do it here in our terminal. I'm going to switch back over to this screen since we're kind of going out of order here, and I want to preserve my bash history. So we can do curl -I, send a post request. Let's get our endpoint here. Yeah, there's that. Oh, we don't want the 9090, but that's okay. We can just delete that. Okay, so we got a 200. Let's go back to Prometheus and refresh. We're still running 9092 here. Did my target not get updated? Is the config map not getting updated? I mean, I guess a simpler solution would be to just change my pod, but I really want to see why this target isn't getting updated. Anyway, for me, this was the most interesting part. I would be curious if there's an easier, more dynamic way of adding pods to a Prometheus server so that you're not going through and fighting this kind of stuff. But ultimately, you're going to have to tell Prometheus somehow whether this configuration is generated like the way we're doing it now, manually or dynamically, using some higher level tooling that may or may not exist in the ecosystem yet, to go in and automatically do a lot of this for you would probably be an easier approach. But yeah, again, this is ultimately what needs to happen to get Prometheus to check your app. So let's check our config map. So the config map is named Prometheus core, and it's in the monitoring namespace. So let's do km get config map Prometheus core. Let's OYAML this thing. Okay, so here's Kris Nova TGIK app. I know this is hard to read. Oh, I did some weird encoding here. let's just edit it. KM edit config map Prometheus core. Oh, and Matea says, yes, you can use annotations and deployments and other resources to tell the Prometheus service discovery to scrape your service. You can create a service monitor. I thought the service monitor was a primitive that the Prometheus operator that the CoreOS folks did. I didn't realize that was actually a native part of Prometheus. Can anybody stick a link to the service monitoring stuff in the markdown file for us? So yeah, let's just edit this here in line and see what's going on. Which would be cool because then all we have to do is we have to add an annotation or a label to our service, and then Prometheus should just honestly pick it up, which is way easier than what I'm doing right now. Matea says service monitors are for the Prometheus operator only. Yeah, okay, so Mateus confirmed what I had to say. So yeah, it's a CRD, it's not built into Prometheus itself. Okay, so this goes back to what I was saying a second ago about having some tooling to help you automatically do this in a clever way. I think the annotation approach is one good way to do it. There definitely could be others. You could even look at doing some sort of type of service discovery or some sort of scraping mechanism that would go through and look at different services, or maybe even certain services and certain namespaces. There's a lot of different things you could do there, but I just think the idea of having it load dynamically is nice and convenient. So exploring different methodologies there would be cool. Now I want to go home and write code. Okay, so let's scroll down. Here's our job name. We're almost there. Okay, so Kris Nova TGIK. So this is running 1993. So I'm guessing that the reload, oh, it did work. Okay, so maybe it was just hanging behind. I thought maybe the reload didn't work, but it looks like the command that Matea suggested did go and actually reload. And now our TGIK app is up and running. Okay. So let's talk about what's going on here and how we were able to glue all of this together. Because this is basically, getting instrumentation working in your program and getting Prometheus to read the instrumentation bits that your program is now spitting out on the /metrics endpoint. Okay, so we created a Go program. That is this main.go file here. And we used the Prometheus default handler, and we told it to listen on /metrics. We then stuck it in a container, pushed it up to Docker Hub, and created a deployment in Kubernetes, and took a service to expose that deployment internally to the rest of the cluster. And we did the port remapping to the default port here, which is 1313, to port 9093. That is then defined here in this bit of YAML as well. So this target definition is a Prometheus level construct. We were just talking about how the Kubernetes operator that Joe used in his episode that our friends at CoreOS and Mateus here are working on make this whole thing a lot simpler so that you don't have to go in and actually add a manual target like what I did here. Anyway, after that's all up and running, Prometheus can then begin to scrape your newly created Go program and start to track those metrics. So let's see what Anthony says. He says, yes, and it's not recommended to use the operator and do it. It's now recommended to use the operator and not do it manually anymore. It's super cool, and I couldn't go back to the old way. Okay, so I definitely am interested in learning how the operator would go through and manually discover various services based on annotations. So that sounds cool as well. But ultimately, Prometheus is a monitoring tool that doesn't have to be ran in Kubernetes, which is where a lot of this sort of like kerfuffle of having to change configuration files even comes from in the first place, is trying to take Prometheus, which is basically our data store, and use Kubernetes primitives to expose the metrics endpoint so that Prometheus can go and scrape it. So if we go to Prometheus, we know we're good, and we can kind of like hover our, how did I do it? Yeah, you like hover your mouse over it here, and you can actually see some meta information about what Prometheus is gathering in your application, which again, this is the default stuff. Software group says, does anyone have the latest document of how to configure the Prometheus operator to monitor an etcd database in Kubernetes 1.11? Yeah, feel free to add it to the doc if you would like to. So let's look at Grafana, because this is where we're really going to start to be able to visualize this data. Okay, so I wanted to create a new dashboard for the TGIK app. So I think I got this down where I don't need to look at the documentation, but there is some really good docs out there that I used when I first did this for the first time yesterday. But let's see if I can just do this from memory. So if we do create new, we're going to tell it to make a graph. We all know how much we love graphs here. And we can actually see that this really interesting graph was created for us. And the reason this graph looks really interesting is because if you right-click here and go to Edit, you can see that we have this data source that's called fake data source, which basically I think is a data source that just looks really pretty. So the first thing we want to do is we want to get rid of our really pretty data source, and now we're going to make it so that we're going to have really ugly data sources that we hopefully can turn into really pretty data sources a little bit later. So if we look at, let's actually just name this dashboard really quick. So let's go back to Edit, let's go to General, and we're going to call this the TGIK app dashboard. So I should be able to save this thing, which I go up here and I hit save. We're going to call it TGIK app. And so we saved this new dashboard. So if you look at how this Grafana is set up, you have to define a data source, which is just one of the many places Grafana could be pulling data from to revisualize on a graph. In this case, Prometheus is our data store. That's going to be regurgitating all of our time series data, and we're going to define Prometheus as one of our data sources. So that's done here. And basically, we use kubedns to hit the Prometheus deployment on port 9090, and it's pretty straightforward. Okay, so now that we have a data source already pre-configured for us, we can go back to our dashboard here. Let's see, how do I do this? Go home and go to our TGIK app dashboard. Pablo says, how to install metric server 0 through 0.1 with EKS. I have a problem with CA certificates and cannot get metrics. That's a good question. If anybody has experience with getting a Prometheus stack of sorts up and running on EKS, maybe let Pablo know and you folks can sync offline. I've never been able to set that up before. I've only used EKS once before Pablo. But feel free to put a note in the markdown file or ask the question in the issue tracker, and we can see if we can track it that way. Mateus says, Pablo, I think it's better to ask this in the Kubernetes Slack in SIG instrumentation. Which, actually, that's a really good point, Mateus. No, it's a really great place to ask questions, but if you are using Grafana or Prometheus or any of the monitoring style tooling, SIG instrumentation is a really great resource with a lot of folks who are working on these projects to get together and help you if you ever get stuck along the way. Also, Pablo, if you would like, I'm going to take off my Kris Nova Heptio TGIK hat and put on my Kris Nova SIG AWS chair hat. If you want to ping me offline, I can also ask SIG AWS, and folks internally at Amazon routinely join that call, so they might have some experience there as well. So feel free to do that if that would help you. Okay, so let's switch hats back to TGIK now. Okay, so here in our dashboard, we don't have any data points because we have to add some. And this is where I could, last night I was playing with this, and I spent probably 2 or 3 hours just looking at all the different data bits you could get from an application that's just default. And there's a lot of stuff going on here, and we're going to see some of those. So we're going to add a new metric here. So we come in and we pick our Prometheus data source. I want to make sure I get my verbiage right here. And then from data source, we want to add a query. And so in order for us to build a query, we can actually do metric lookups over here in this thing. So if you just stick your mouse cursor in it, you actually can go and you can see all of the different metrics you can go. So in this case, I want to do go, it was go routines or something just to get us started. Yeah, go routines. Okay, so now we have some data. But let's see what's going on here. So if you look, this bottom piece of the graph here has all of these different color-coded definitions. I'm completely colorblind, so I can't even tell these things apart. So most of today is going to be me isolating these based on job labels. So if you look in here, you can see there's this little, it looks like JSON, but it's not quite perfectly JSON inside of these curly braces that say the instance is equal to the name of the instance and its Kubernetes nodes. And if you keep looking further down, you can see app is equal to Prometheus, component is equal to core, and then there's our instance type as well. So we want to find the TGIK app. So I think what we want to do we see that in here? let's just try to define this and see if we can get anything. So how we would do that is we would do curly brace app is equal to TGIK app, double quote in curly brace. And then I don't know if there's like an enter button or anything, but what I've been doing is just clicking in this gray space down here, and that will reload our dashboard for us. Okay, so I don't see the TGIK app Go routines just yet. Mateus, I'm guessing this is another brilliant comment of yours. Grafana version 5 has a really beautiful type ahead for writing metrics. Give that a try at some point. Okay, so in the new version of Grafana, it looks like this user experience here is a little bit better. So we can't get Go routines. Let's see if there's another one where we can find the TGIK app. So let's go and let's type Go again, and let's see if we can do, we won't do Go, let's do HTTP requests total. And we want to move this back to the beginning, and let's see if this gives us any results. So I'm guessing for some reason the TGIK app isn't being populated. Let's see what's going on. Let's see if we can find it in here. Mateus says, I think clicking in the gray space is correct. The query is go routines job equals TGIK app. Thank you, Mateus, again. So let's try our go routines. So yeah, so this is kind of like you're getting to see some of the user experience here. You got to go back and delete this, and then we want to add our curly braces. And I think Mateus says its job is equal to TGIK apps, or app, singular. So let's run that and click in the gray space. Okay, perfect. Okay. Sorry, I'm going to actually do this offline. Okay, hashtag sick TGIK day. Okay, so go routines job is equal to TGIK app. And you can see here we now have one lovely color with our simple go routines running. Right now, if we go and we look at our program, let's go into Goland, and let's go to main. You can see that we actually don't create a new go routine anywhere in here, and we're just doing listen and serve in sequence, not concurrently. So that would make sense that we're only really seeing 6 go routines here, which this is already kind of cool because you're getting some visibility into your Go application. For instance, the world's simplest Go program with a handful of Prometheus and Logger lines in it is generating 6 Go routines, which is interesting because you would really think there would only be one. So there's definitely some other things going on in your program thanks to our friends over on the Go team who have built this wonderful programming language for us. But yeah, we're definitely getting some visibility into your app. So yesterday at this point, I was like, I wonder if I can just totally like spike up the number of Go routines and see a spike in our data here. So this is where I ended up writing that Kubernetes fork bomb that I tweeted about last night, where I just created an unlimited supply of Go routines. So I'm not going to do that today, but instead I'm going to write a really simple for loop that's going to actually simulate a spike, and we're going to actually be able to see the amount of Go routines go up and see that regurgitated here on the TGIK app dashboard. And actually see what the data looks like so we can see what our program is doing in real time. So how we want to do that is let's define an I is equal to, let's do 1,000 Go routines. And we're going to do for in is equal to 0, in is less than I, in plus plus. So this is just a good old for syntax here. If you've ever written C or Java before, this is going to look familiar. But all we're doing here is we're saying create a new variable in, set it to 0, continue to loop and check this condition that n is greater than or equal to I, and at the end of every loop, go ahead and run this in plus plus, which just increments n by 1. So we're just going to loop through 1,000 times is all that's happening here. So while we're looping through 1,000 times, we're going to just start a new Go routine by doing go func, and in here we will do a time.sleep. Where's our random thing here? Yeah, so this is what I had earlier. So this is just going to sleep for like some random amount of time, which is going to be some random int between 0 and 100, and it's going to do that for that many microseconds. So we're going to get a little bit of like authentic looking data here. So for each one of those, go ahead and spike, and we're only going to do that spike once, which is right at the very beginning, and then we're going to go ahead and start our server. So we're going to go ahead and repush this now, and we're going to do that by doing make container push. And then we can use that TGIK scale scale command that I typed earlier to actually go and reset our app. So that thing, turns out, is going to be useful. And that's how we'll reset our pod. So let's do TGIK app. Perfect. So here we're going to set our TGIK app, not the Prometheus, our TGIK app equal to 0. And then we'll set it back to 1. And now we've known that we've gone and deleted a pod and created a new TGIK pod. That pull policy is set to always, so that's going to pull down the newly created Docker image and get this thing up and running. So if we go back here to Grafana, I'm curious to see if we're going to be able to get a spike in our Go routines here. So let's see if km get PO. So TGIK app has been running for 21 seconds. It should have looped through those Go routines pretty quickly. I didn't add anything in the logs, but let's just go see what's going on in our logs here. So km logs, the name of the pod, -f. Okay, so we got to the service metrics log line. So we know we've already gone through and actually created a bunch of Go routines. And we might actually miss the number of Go routines depending on how the default handler here works. I don't know if it behaves in such a way that you're going to get that metric reported no matter what, or if it just samples the data in your program randomly. In which case, if it does sample it either random or in some sequence, there's a chance that that sample will be taken at some point in time other than this is happening. So, Mateus, this is going to be your question for the day. I feel like I might actually be able to stump you with this one, but we'll see. Do you know how the Prometheus HTTP handler handles sampling things like Go routines, and whether or not we're at risk of losing this loop that I just wrote here? Which is really interesting for a software engineer, because now we're in this sort of place where like things could be happening or potentially be happening, and our metrics library might very well just miss it. So curious here. Let's see if we go to our graph and if we can see anything. So we're not seeing anything yet, and I'm wondering if there's like a way to like zoom in on this like section here. Oh, okay, here we go. So we got some more data. I had to hit this refresh button here. Mateus says the metrics are collected at the time the HT endpoint is hit, which right now we have that configured to 1 second. So there's a good chance that we should get some of these. I can definitely bump that sleep up to, actually let's just do that for good measure. I want to see if we can get a spike in our data here, which is interesting. So let's do time.second. Let's really draw this thing out. And then let's go ahead and rebuild this thing. So make container push. And then let's redeploy it as soon as it pushes. And I guess that would make sense that the metrics are collected whenever it's hit, because it just passes in a handler command. I was just wondering if it did any cool caching behind the scenes, or like how intimately it went with the Go source tree itself. Okay, so now that that's built, let's scale down to 0 and then scale back up to 1. And let's go back to our dashboard here and reload and see what we can get. Oh, we lost our query. Interesting. I guess I had to save that. So let's add our query again. Wait, what's going on here? Delete this one. And add Prometheus, add query. There we go. So here we want our Go routines. Job is equal to TGIK app. I love how this was supposed to be a short episode today, but we're already an hour and a half in. This is just what happens in TGIK whenever I start hacking. So let's hit the gray space. Okay, this is cool. So we have a spike in our data finally. Anthony says, click on the last 6 hours and you can set it to auto refresh like every 5 seconds. So from last 6 hours to now, refreshing every 5 seconds. And let's do Now minus 6 hours. Let's do now minus, let's do 15 minutes. I wonder if that will work. Perfect. Look at this. We're getting like a real, like I feel like a real observability engineer here. Like we have a spike in our graph that we just created by instrumenting our code and doing some cool things. And if you look here, you actually can see that the Go program is super, super linear, which this is exciting if you think about how much work was put into the Go programming language to make this as linear as it is. Which basically says that we're creating all of these Go routines relatively in a uniform amount of time at runtime, sleeping for exactly 1 second, and then slowly dropping off. And we're so granular that second is spread pretty evenly over the course of, it looks like, about 2 minutes here. So that's really cool to see the Go program go and actually do this. So anyway, here's our spike in our data. And we can have different queries here, and we can actually go and start to put different metrics into our application, which I'm going to go through this last little custom bit of writing your own metric here at the end, and then we're going to sort of wrap everything up for the day, so maybe only 10 more minutes, and then I'll get out of here. So if we go back to our reference links here, we're going to look at this instrumenting Go with Prometheus, which this is the first thing that I brought up and probably the last thing I'm going to do. Which has this little snippet here. So we're going to borrow quite a bit of this. Matthias says most of these metrics are stateless and collected when requested. So that's a really good point. I think what Matthias is saying is they're only taken when being requested, meaning that Prometheus is actually ever going to go and take them off of the metrics endpoint whenever somebody asks for them and store them because we're using them. So that's pretty cool to know that everything is sort of stateless, and then we're not going to start actually tracking it until we need it at runtime. Okay, so in this example, they say, let's go ahead and start off by calling this record metrics function, which is defined here, which then launches another function. So this is the idiomatic Go Nova. I think that having a Go func immediately inside of another function is a bit confusing for folks. It might have been interesting to see if we could have gotten rid of this line and just had a simple for loop in this record metrics function, and then just put the word Go in front of this line here so that we knew that we're calling this record metrics function concurrently, and then we can actually then turn record metrics on or off concurrently just by adding or removing the word Go there. So anyway, we'll start off by just creating a function similar to this one in our program, and we'll do that down here at the bottom. We'll call it TGI metrics, and we're going to do just that. We're going to get rid of this, and we're going to get rid of this. And let's save that, and looks like ops processed is something that we need to import. Where is ops processed? Okay, so now let's look at and see what's going on here. So in this example, they define a new variable called ops processed. They use this prom auto, which is, I'm assuming is a Prometheus auto, new counter primitive, which is coming from, I'm assuming, this package here, which is in that client Golang Prometheus client library we looked at earlier. So I bet I can just copy this whole snippet and grab this into our, and paste this into our application here. So for prom auto, let's see if we can auto detect it. Auto, not seeing it. So let's just add the line manually, and we'll do a dep ensure as well. So let's grab prom auto and prom HTTP. We'll go and import these into our code base here and here. We already have prom HTTP. And let's do a dep ensure and see what happens. Dep ensure -v. I know I brought this up on a previous TGIK, but every time you do a dep ensure -v, this little source output here, I got to help work on, so I wrote a lot of this, so every time I run it, it makes me really excited, because I spent a lot of time making sure that all of the little ones and zeros and everything line up meaningfully on the left. So we have some errors here. Let's see what's going on. Looks like it's yelling at me for Kubicorn. Please move or remove them before you switch branches. Solving failure. No versions of Kubicorn met constraints. Oh, it's just because I'm importing my Kubicorn logger. Let's see. I'm going to just go ahead and delete this, and we're just going to start fresh. And we can delete vendor as well. Okay, cool. So now let's just do a dep init and a dep ensure. Dep init minus v, and then we'll do a dep ensure again. I really want to go and see which functions are available in this prom auto package. So as soon as we get this thing imported, I want to kind of just look and see off the cuff what looks exciting. So for Prometheus counterops, I'm assuming counterops is short for counter options, and we give it a name and a help. And then basically ops processed is just some sort of incremental counter that we can use arbitrarily. So you would want to use an incremental counter arbitrarily in your app for a number of things. This could be anything from like how many events have you processed, maybe how many requests have you taken, maybe how many requests of a certain type. But as you're looking at instrumenting your application, as your application is taking action and doing things, you would then be able to have some sort of variable or probably some sort of package that behaves like a singleton. I know package level state and singletons in Go, where you would be able to actually go and increment some counter. So we can start to look at really exciting patterns in the Go programming language, like maybe we have some sort of higher level struct with all of our Prometheus auto counters and types in them that we can access from anywhere in the package. Maybe we pass a global one around. Maybe we have one per file. There's a couple of different ways we could look at doing that. But ultimately, as you're instrumenting your application, you're going to want to find metrics that are meaningful to your app so that you can actually go and get them up and running in a graph and see if any of these ever spike or if there's ever any interesting trends in your application. So let's see if we're done initting yet. Okay, it's still doing its thing. One of the really great examples I could think of with Prometheus counters, I really keep going back to this, but I think the event-driven development or any sort of events processing would be really handy to not only have like a global number of events, but to actually go and have like a counter of different types of events that you're processing. So if you have some sort of data pipeline and you get say 7 or 8 different types of events that might come through, maybe we have orders or refunds or whatever, you're actually able to do a little bit of segregation. So you would be able to see on a graph at runtime how many of the different types of events are coming through your system. And you could process that however you want with Prometheus and a tool like Grafana just by adding a simple counter to your application. So let's go back and see. Matea says, haha, yes, personally I always try to create a Prometheus new registry in main.go, and then all the metrics and then pass those around, no globals. So yeah, this is like a stylistic thing. I know a lot of people who say that you should never have package level state in Go. I know a lot of folks who enjoy passing things around globally. It looks like in Mateus's example, which as soon as this is done, which it looks like it is now, there's some built-in Prometheus new registry primitives that allow us to sort of interact with this new registry thing. And it looks like they've already built that for us, which is handy because I was sort of just talking through what it might be like to build that on your own. Okay, so anyway, we should have our dependencies checked out. So let's go back to GoLand and see if our prom auto here wants to look itself up. Aha, okay, so that worked. So if we go through and we look at, let's see, where were we? This prom auto new counter, we can actually go through and see what else we have here just by doing prom, did I spell that right? Prom auto dot, I guess it might still be indexing. We can come back to this in a second. So let's just build the rest of our program and then we can look up and see what the library has. And then so in our record metrics, we just have this for loop that just does a sleep for 2 seconds and it just increments. And then we just call record metrics. So this is pretty straightforward. This is like really easy. So let's mutate this a little bit and give us a little more interesting spike here. We're going to do this thing again. Just because I think random values are interesting. So times.sleep, time.duration, random int 100 times.time second. Okay, so that looks good. And then we're doing an ops processed.inc. Can we see what else we can do on ops processed? Okay, so we can add one to it, or we can just do increment, which I think is just like basically doing a plus plus. What does desk do? This is interesting. So this is the counter here that's built into the Prometheus library for us. Matthias says, however, these metrics are not populated by the API server and thus are noise. Could you expand on that a little bit more, Matthias? What you mean by they're not populated by the API server? So this just returns a descriptor for the metric, which I think is just part of what you would define in the metric, which is pretty straightforward. Okay, so let's go ahead and run this. So after we do our spike and go routines, let's go ahead and do go TGI metrics, and we'll run that concurrently as well. And then we'll start our server. So let's refresh this, make container push. Oh, I guess I missed one. Matthias said, please read the message above the last one. Due to the package global metrics, the Kubernetes API server apparently exposes etcd metrics because it vendors some packages of etcd. Ah, got it. However, these metrics are not populated by the API server and thus are noise. Okay, so he was referring to how Kubernetes attempts to monitor etcd. I was like, what are we talking about here? Is there some other API server I need to register my metrics with? What's going on? So yeah, we're good. So make container push. Let's do our scale command again. I feel like today's episode is just me and Matthias talking back and forth, which is totally rad. So let's do our scale, r equal to replicas equal to 1. And you're not spamming at all. Folks are here to learn, and you're an expert on this and one of the maintainers of a successful operator. So I think folks are excited to hear what you have to say. So if anything, we should be thanking you, Matthias, for helping us out today. And also, like, I hope I'm saying your name correctly, because I've only said it like 100 times in the past hour and 40 minutes. So replica is equal to 0, and then replica is equal to 1. Okay, so that thing is scaled. So let's go back to Grafana and see what we got here. And we should, if everything worked, which we're going to see if this worked, but if everything worked, we should have this myapps processed ops total, because we called it the myapps process ops total, which I should have given that a better name. But anyway, this should now be appearing on the /metrics output. So Prometheus should just pick this up, automatically register our label, and then we're off to the races and we can query for it directly in Grafana. So let's go see if we can find it here. Okay, so our new app that we just pushed is running. So we can see our spike and our go routines that are randomly sleeping for some random amount of seconds that still behave super linearly, and that's really exciting. So we can do, what was the name of this thing? My app process ops total. Okay, so let's go here, and look, it's already found it. That's really cool. And let's put my app processed ops total into this space and click here, and we should see a spike, shouldn't we? Is it just because I'm viewing this thing too late? And actually, you know what I want to do is I want to save. How do I save this one? Because I can add both on here at the same time. I think, what do I just go up here and hit save? Yeah, I think so. So now let's add a query, and we'll do our go underbar go routines. And we're going to add our job is equal to TGIK as well. And we should have 2 metrics here. Yeah, so here's our go routines. And I'm not seeing this new metrics counter go up. Is there a bug in our code here? What's going on? So here we call, let's add a log line and see what happens. Calling TGIK metrics. So we call that, and then we know our server starts, which our server obviously is working, or we wouldn't have gotten that metric in Grafana. So we know we're calling this function TGIK metrics, and then we just do a for loop to run indefinitely. That just says sleep. Oh, okay, because I bet we're sleeping for seconds here, meaning that, actually no, that shouldn't matter. It should be working. Why are we not getting a spike in our data? Let's maybe try to reload our app and see what happens now that we have both up and running. So reset that back to 0, reset it back to 1. Automatically refresh every 5 seconds. Okay, so this is so fast. I love watching how fast the Kubernetes scheduler actually is. So it like so much just happened when I hit that 0 and changed it to a 1. It hit Docker Hub, realized there wasn't a new container, and launched a new container with the existing image it already had locally. Which doing all that so fast is just cool. Like, we can kind of get a lot of that for free in Kubernetes, and it's fun to take advantage of it. Okay, so anyway, we're seeing our spike in our Go routines. We're not seeing a spike in our ops counter. So I want to try to debug this a little bit more, and I think it's going to be really interesting to actually go through and learn about all of the different types of counters that we could do with Prometheus, and all the different ways we could start to gather metrics. In the future, I would really like to talk about implementing this on a real-life use case. We talked about doing the cluster API work, and when I looked at it, it still was a little bit new. So maybe in the next couple of months, as the cluster API AWS stuff that we're working on comes to life, I can actually open up a pull request, and we can do like a short little segment here on TGIK where I'll actually go and add a counter for things like you know, how many times somebody has made a mutation to the cluster, or maybe a counter for how many nodes we have, or how many times we've hit the AWS API would probably be a great metric to have in an operator like one for the cluster API. Matthias says, please click on the only MyApp metric in the graph panel again, as this doesn't go up to 1K yet. Okay, so let's see what Matthias is saying. How do I do that? I think that's this button here. Oh, I see. Okay, so that goes up to 1K, and then that goes up to 1. So, wait, this is what I want to do. Oh, interesting. Okay, so why does this not... Okay, I see what's going on now. So let's look at our code and explain this. So we're just doing this for loop, and we're sleeping for some amount of time, and we're incrementing slowly. So this thing is counting up slowly. On our graph, I foolishly thought it was a reasonable assumption to think that the graph dimensions that we were using for the Go routines that instantly shot up to 1,000 and came back down would be relevant. But as Matthias pointed out, we actually need to inspect them independently of each other and have just going up to 2 or 3 here. So here you can see what's happening inside of our application is we're sleeping for some amount of time. We're sleeping, that sleep expires, we increment the counter by 1. We sleep for a random amount of time, that sleep expires, we increment the counter by 1. So if we let this thing run for about 1,000 more iterations through, which could take quite some time, we would actually be able to view both of these on the same graph, and the bottom graph would look like this slowly incrementing line, and the top graph would be just a big spike as well. And Anthony says, yeah, send the metric to the secondary y-axis. So how do I was just about to ask that. How do I send this metrics to the secondary y-axis? What do I need to click on? Oh, axes. Okay. So we have left y and we have right y in our x-axis. So here, resolution, where do you tell it which axis to go on? If you want to let us know, that'd be great. Anyway, it's an hour and 15 minutes in, so we've been doing this for quite some time, so I really need to wrap up here. So at the end of the episode, we'll try to get this graph up and running here in a second, but at the end of the episode, I like to start saying goodbyes a little bit early, and then I'll kind of recap everything that we've done today for folks at home. So yeah, we were able to create a new Prometheus deployment using some older YAML, but some interesting YAML that talked about the various complexities in getting Prometheus, the alert manager, and Grafana up and running. We learned about the Prometheus operator that Joe played with, and Matthias here talked about how the differences between how I did things today and the Prometheus operator, and learned that one of the big wins of the Prometheus operator is it can dynamically discover pods based on service annotations, which would have alleviated all of the target YAML-y stuff I did earlier in the episode. After we had Prometheus up and running, we were able to write a small Go program, which is here in our TGIK repository. And in this Go program, we were able to perform a couple of different tasks and actually get those metrics up and running in Grafana after they were stored in Prometheus. So the first one we did was we did this really fast spike in Go routines. And the second one we did was this example of creating a new counter that we called ops processed, and we incremented this randomly over the course of a very long time. And then, of course, we gave it a name. The interesting part about using the Prometheus libraries in your Go codebase was this name populated extremely quickly, and you could change this to whatever you want and get it very quickly in Grafana, which would be very handy for debugging something in production. Within probably 30 seconds or so, I was able to create a new metric, reload my pod, and then get that in Grafana very quickly. So we're already starting to see a lot of the advantages of Prometheus and the tooling that's given to us as software engineers. So let's see. I'm hoping folks have told me how to do the y-axes really quick. So Mateus said, to change the axes, you need to click on the short green line left to the metric in the graph. So colorblind Nova here is going to try to figure this out. So click on this. So go to, look at that. Look at that beautiful graph. Okay, so this is, let me switch over. Okay, so this is like the graph of the day. I really want, actually, I'm going to take a screenshot of this really quick so I can tweet it. We finally got like a really cool graph here. Bam. So yeah, so thanks for joining. We finally got our beautiful graph using custom Prometheus instrumentation in Go, and we were able to see some exciting things about running a new program in production, or in Kubernetes. You can run it in production or wherever, and creating new metrics using the client libraries that the folks at Prometheus have offered for us. So that's all I have today. Thanks for joining, everyone. Sorry this has been such a long episode. Sorry that I'm sick. Hopefully the next time will be a little bit easier for me to talk to folks. And let's just see what everybody is saying in the chat here. Matea said, really enjoyed this. Hope you get well over the weekend, Kris. Yeah, unfortunately, I think I need to cancel one of my mountain climbs this weekend. I just canceled some of my travel for next week, so I think I'm going straight home and laying in bed and going to be making soup and watching movies all weekend, which is probably going to be good for me anyway to chill out for a little bit. So Bogdan says, at least in Grafana 5x. Okay, so anyway, that's all I have today. Thanks for joining, everyone. Bogdan says, great episode, get well soon. And then thanks for bearing with us through the almost 2-hour-long TGIK episode. I'm wondering if we've set any new TGIK records for longest episode. That was supposed to be my shortest episode, which is hilarious, today on TGIK. Carlos Santana, great name, says, can you show how you added the other y-axis? Yeah, so Carlos, so here we have the left y-axis and the left to right y-axis, and we can define some of the configuration. And then if you actually go, actually you can have any of these tabs open here. You come here and you can see all of your different data sources, and you can right or just single click on them, and you can change their color, and you can tell it which axis you want it to go on. And so now we have on the left side here, we have up to 1,000 for our 1,000 Go routines. And on the right side, we have our counter, which is slowly going up in the background. And if we let this thing run long enough, these two axes would start to approach each other and ultimately become very similar in nature, and our graph would look very differently. Actually, it might look close to the same, just zoomed out a bunch. So Roy says, thank you, Kris, get well. Anthony says, thanks and sorry we won't see you again in London next week. Yeah, I haven't announced it to folks yet, but I definitely, I'm too sick to be traveling. I really shouldn't even be here at the office. I don't want to get anybody else sick. So unfortunately, I'm not going to be in London at the beginning of next week. So it's totally cool, because I'll be back again for Velocity in London a few weeks later. But I'm going to miss everyone, and I'm going to have to let Ivan know that the Kubernetes meetup, I think next Tuesday night in London, that I'm not going to be able to make that appointment, unfortunately. So Michael says, thanks, get well soon, but I'm not even going to try to say it, but he said cheers, and good night all. And Carlos Santana says, thanks, great show. No problem, Carlos. I really enjoy your name. So thanks for joining, everyone. It's been real. I got to go back to my face here. I hope everybody has a good weekend. Feel free to hit me up. We love doing TGIK as always. But yeah, hit me up if you have any questions, and I'm happy to help you out. So instrumenting your code with Prometheus. All right, I'm out of here. Bye.